Hello and welcome to the seventh module of the unit devoted to Guy Brousseau and the theory of didactical situations in mathematics in the project ICMI Awarded Multimedia Online Resources. We will present a very important concept of theory of mathematical situations, which is the notion of fundamental situation. But first, we will summarize the key points introduced in the previous module. In this slide, we will schematize the module's organization of Brousseau's unit. In Module 1, we have introduced the theory of didactical situations in mathematics as an epistemological revolution. Then, in Module 2, we have introduced the dual aspects of knowledge, that is, situational knowledge and institutional knowledge. Those modules have been the basis for Module 3, where we have studied the concept of mathematical situation. And in the following modules, we have shown and analyzed examples of mathematical situations. We will now follow a similar path, which is to lay the basis for the concept of the fundamental situation in Module 7, and thus to develop different examples in Module 8 to 10. We'll start by reviewing the key point of the previous modules and then take a step-by-step approach to the concept of fundamental situation. We will now have a look back at the most important element of Module 1 and Module 2. In the first module, we have claimed that the aim of theory of mathematical situations, TMS, is to reconsider mathematical knowledge in terms of situations. We then came across the first version of the fundamental principle of TMS as follows. To every piece of mathematical knowledge, there corresponds a collection of situations which can be solved using this knowledge. In Module 2, we linked this principle to Brousseau's fundamental distinction of the two aspects of knowledge, situational knowledge and institutional knowledge. This distinction has allowed us to reinterpret the fundamental principle of TSM. To every piece of mathematical institutional knowledge, there corresponds a collection of situations which can be solved using some situational pieces of knowledge. Let us now go back to Modules 3 to 6. In Module 3, we took up the question posed by Guy Brousseau in his lectures in Brazil. Why study situations if what is at stake is to acquire institutional knowledge? We have tried to answer this question in the following three modules, Module 4 to 6, by emphasizing, as Brousseau says, three types of situation to which correspond three types of manifestations of mathematical thinking and language. These three types of situation, action, formulation, validation, make it possible to offer conditions for provoking a process of institutionalization. This process initiates a transformation of the status of knowledge from situational knowledge to institutional knowledge. We will now return to the epistemological revolution introduced in Module 2. Brousseau's revolutionary and very ambitious project is to consider mathematics as the production of situational knowledge, that is, as useful answers in situation. Let us recall that the reasons given by Guy Brousseau for this epistemological revolution are the following. By comparing problem solving with the history of mathematical concepts, it appears that certain conditions which disappear from the final statements play an essential role. Thus, each mathematical concept can be associated with some conditions in which a human being is led to produce, as a response, a specific behavior, testifying to a certain knowledge of a mathematical concept. At the end of Module 2, we raised a very important question. This is what we are going to discuss in this module and in the following modules. How can we ensure that the situational pieces of knowledge encountered in situation correspond to a given institutional knowledge? This question refers to the institutionalization process that makes it possible to move from situational knowledge to institutional knowledge by gradually changing the status of situational knowledge. We have started to describe the institutionalization process in the previous module. Knowledge for action in the action situation, formulated knowledge in the formulation situation, validated knowledge in the validation situation. We will now focus on the transposition process, which in TSM starts from a given institutional knowledge. The aim of this transposition process is to understand which pieces of situational knowledge correspond to a given institutional knowledge. We would like to point out that a different and broader sense of didactic transposition had been developed by Yves Chevallard. You can consult Module 2 of Yves Chevallard's unit in the AMOR project. We have just said that the aim of the transposition process is to understand which pieces of situational knowledge correspond to a given institutional knowledge. But this correspondence between situational and institutional knowledge is never obvious. As we have seen in Module 3, in a given situation, situational knowledge is determined by the interactions between the actant and the milieu, not by the institutional knowledge that will emerge at the end of the institutionalization process. The question of transposition control is thus, how can we ensure that the situational knowledge encountered in situation is an adequate transposition of a given institutional knowledge? The concept of the fundamental situation, which is the aim of these and the following modules, is closely linked to this question. In order to move toward the idea of fundamental situation, we need to introduce the notion of meaning of institutional mathematical knowledge. We will start with a simple example of subtracting natural numbers. 5 minus 3 equal 2. If you have 5 cubes and you take away 3 cubes, you get 2 cubes. That is, one meaning of 5 minus 3 equal 2. Now take a number line. If you start at point 5 and you go back 3, you end up at point 2. This is another meaning of the same operation, 5 minus 3 equal 2. We will now show that these different meanings have some different consequences. If you have 2 cubes and are asked to remove 3 cubes, this is an impossible operation. So, you cannot interpret 2 minus 3. However, if you take a number line, start at point 2 on the number line, and move backward by 3, you end up at a point on the line. You can give this point an abscissa, which is minus 1. So, you can interpret 2 minus 3 and give the answer minus 1. Let's now return to the question of transposition control in the case of 2 minus 3. We have just seen that if the milieu of situations consists of cubes and more generally of discrete sets of objects, operation 2 minus 3 has no meaning. In order to obtain a transposition of the meaning of 2 minus 3, we have shown the necessity of a number line as a component of the milieu. Thus, working on the meaning of numbers as position from the beginning of schooling may have an influence on the knowledge that these students will be able to invest later in situations involving relative numbers. In Module 9, we will work on this issue by introducing a fundamental situation involving numbers as position. Brousseau's engineering process begins with the deconstruction of institutional knowledge, which consists of searching for all the possible meanings related to the usefulness of knowledge in situations. However, Brousseau takes the following question very seriously. How can we control, from an epistemological point of view, that there is a necessity to consider some meanings as different? It is possible to consider multiplying didactic situations that each illustrate different aspects. But this didactic strategy is questionable. It's time-consuming, it gives too rich and fragmented a picture, and the overall meaning may never be conveyed. It is therefore advantageous to have a fundamental situation that can generate this field. The function of a fundamental situation is to summarize this global meaning in order to allow the number and diversity of its occurrences to be deployed according to the needs and possibility of the teaching. During the research of a fundamental situation, a question arises. How can we control, from an epistemological point of view, that there is a necessity to consider some meanings as different? We need a method in order to minimize the number of meanings needed to take into account a given institutional knowledge. For example, the meaning of subtraction based on cardinality is sufficient to define subtraction for a natural number. On the other hand, this meaning is not sufficient to define subtraction as an internal operation in the set of relative numbers. That is where the search for a fundamental situation comes in. The idea is to look for a very simple and general description of a kind of empty shell situation that would generate, through a set of variables, the different situations corresponding to each meaning of a given institutional knowledge. We thus obtain a new formulation of the fundamental principle. For each mathematical institutional knowledge, there is a fundamental situation that generates, through a set of variables, the different situation corresponding to all the meanings of this knowledge. This search for a minimum of fundamental situation will lead to a functional organization of knowledge. This is TSM's answer to the need for an epistemological control to minimize the number of meanings. In the following modules, we will present a process for finding a fundamental situation about numbers. Thank you. You can now proceed to Module 8 of the unit devoted to Guy Brousseau.